All right, we are in the home stretch of Unit 4, Rational Functions. Those of you who know me well enough to know that I got a ball game to go watch. So I'm going to make this as fast as I can, but there is a lot of information in this particular lesson. This is Unit 4, Lesson 7, Reciprocal and Rational Functions Graphing. So first of all, just want to look at reciprocal functions. These are kind of easy. A reciprocal function, the parent function looks like this. Some of these notes, I'm just going to give you this information. I'm not going to have a whole lot to say about it, but I'm just going to give you the notes so you've got them in front of you. So reciprocal function means that you've got just a number in the numerator, and then you've got, something with a variable in the denominator. And I'm just going to draw a little sketch here. It might look something like this. Well, this is the parent function. It looks something like this. It goes this way, and then it kind of has this mirror image going this way. So we're just going to draw a little rough sketch here. The type of graph, this is called, remember how you studied parabola? This is called a hyperbola. Not to be confused with the word hyperbole, which is an English term. The domain of this parent graph is, this is how we're going to write this. We're going to write a little set notation, x, and then this line like this, x such that x does not equal 0. And what I mean by that is there's a vertical asymptote at 0. You see how this graph doesn't touch 0 at x equals 0? So that's how we have to state the domain. It's all real numbers except where x equals 0. So all except the y-axis. The range is all real numbers. So we're going to say y such that y does not equal 0. So it also has a horizontal asymptote at 0, or at y equals 0. And then, of course, we just stated that the vertical asymptote is at x equals 0. And the horizontal asymptote is at y equals 0. If you don't remember what asymptotes are, it's where the graph approaches that line, but it doesn't touch it. So remember, back in, Unit 3, I think, we denoted those with a dotted line like that, so that would be the horizontal asymptote. Okay, so that's reciprocal functions. Standard form looks like this. F of x equals some number a over x minus h plus k, where these are the transformations. These are the vertical and horizontal shifts and all that. H is the horizontal shift, so that is the left and right. Plus shifts left, minus shifts right. Okay, K is the vertical shift, whereas plus shifts up, minus shifts down. If A is negative, the function is reflected. Maybe we'll look at some examples. Across the x-axis. If absolute value of A is greater than 1, represents a vertical stretch. You remember we've talked about this before, especially with the absolute value functions. And if the absolute value of A is a fraction, that represents a vertical compression. The vertical asymptote is x equals h. The horizontal asymptote is y equals k. So whatever the h is, vertical asymptote. K is the horizontal asymptote. All right, moving on. This section right here, put an X there. We're not doing it. All right, so let's look at some graphs on here. All right, so first thing I want to do is look for the asymptotes. So this particular graph here has a vertical asymptote on the y-axis, which is x equals 0. So I'm going to put x equals 0 right there. And then it has a horizontal asymptote right here. So you see this line right here. It looks like it approaches it, but it never touches it. And that is at y equals -2. The reason I do the asymptotes first is because that's going to help us determine what the domain and range are. The domain is going to be all real numbers x. So what you do is you just use this right here. All real numbers x such that x does not equal 0 because it doesn't touch the line where x equals 0, which is the y-axis. And the range is going to be all real numbers y such that y does not equal -2. So these are pretty easy. Find the vertical and horizontal asymptotes first, and then you've got your domain and range from there. All right, so let's look for the vertical asymptote on this one. It looks like it approaches this line right here. I'll just draw a little dotted line right here. So it looks like it approaches that line. That is where x equals -3. So our domain in set notation is all real numbers x such that x does not equal -3. And then let's see, I'll do the horizontal in a different color. Horizontal asymptote looks like it approaches this line right here, but it never touches it. Well, that's at y equals 0. So the domain, the range then is all real numbers y such that y does not equal 0. Okay, let's see if we can go a little bit faster. Okay, this one, the vertical asymptote is here. That is x equals 0. And the horizontal asymptote is here. That's at y equals 1. So domain, wrong color, I'll do the range. Y such that y does not equal 1. And I'm terrible at drawing those little squiggly lines. The range is all real numbers x such that x does not equal 0. Alright, over here, let's see. Vertical asymptote is right here. And that is at, looks like x equals 2. Yeah, wait a minute, I got ahead of myself. Yeah, that's right. X equals 2. And the horizontal is here. And that is, looks like y equals -2, I think. Yeah. Y equals -2. Okay, so domain is x such that x does not equal 2. Range is y such that y does not equal -2. All right, I think we got 2 more like this. Number 8, and I forgot to tell you, this is on page 12 right here. Vertical asymptote looks like it's right here. That's at x equals 4. I think I might have graphed that one wrong. Let's see. 2 over x is 4. Let me go back and look. Oh, I did x minus 4 by mistake. I was like, that is not right. Okay, let's go back and change this one. This should be plus 4. Okay. So that changes that. Here's the vertical asymptote right here. It's at -4. X equals -4. So this graph is wrong, but you don't have to sketch them anyway. And then the horizontal asymptote is, let's go back and look. It's at y equals -6. No, -7. That's 2 below the -5. -7. Y equals -7. Domain x such that x does not equal -4. Range y such that y does not equal -7. Okay, one more, number 9. Hopefully I got this one right. -1 x minus 5. Okay, yeah, I think I got this one right. Vertical asymptote is right here. I made this one really big. That is at 5. X equals 5. Horizontal asymptote is here. And that's at y equals 3. domain x such that x does not equal 5, and range y such that y does not equal 3. Okay, so that's it for reciprocal functions. So this is page 13 in your notes. The difference between reciprocal and rational functions is that the reciprocal functions have just a number in the numerator, and rational functions have an expression in the numerator. So we would write this f of x equals like p of x over q of x, where p of x and q of x are polynomials. And then q of x cannot equal 0 because, you know, you can't divide by 0. Dividing by 0 is undefined. All right, continuing on page 13. We're going to pretty much graph these, but there is one reason you need to simplify this function, and that is to find what we call holes. We're going to get to that in just a second. I'm going to fill in this for you right here. If the degree of p is greater than the degree of q, in other words, if the numerator's degree is bigger than the denominator's degree, then there's no horizontal asymptote. If the degree of p is less than the degree of q, numerator is less than q, then the horizontal asymptote is the x-axis. And then where, of course, where y equals 0. If they equal the degree, the numerator's degree and the denominator's degree, if they are equal, then what you do is you make a fraction, leading coefficient, again, you don't really have to remember all this. I just want you to have it in your notes if you need it. Okay, so leading coefficient over leading coefficient, numerator and denominator. So this is a numerator and this is a denominator. Okay. Identify the holes. Now, the holes are where it's a break in the graph. Basically, there's nothing there. There's nothing at that point. And this is how you find it. And I'm going to show you an example of this because it's going to be easier to show you an example than to try to tell you about how to do this formula here. All right, we're going to look at a few of the rational functions and then we're going to stop. So x-intercept for this particular graph, for number 1, is 4, 0. Vertical asymptote looks like it's at right here. It's really hard to tell. So that would be -4. X equals -4. Horizontal asymptote is, again, it's hard to tell on this graph, but it's at y equals 1. Okay, there aren't any holes. I'm just going to tell you there's no holes. What you're looking for, if you know there's a hole in the graph if the numerator and the denominator have a factor in common. So the numerator only has one factor and the denominator only has one factor, and they're not the same. So that means there are no holes in this. The domain used the vertical asymptote is x such that x does not equal -4. And then the vertical asymptote, the range, use the horizontal asymptote. It's y such that y does not equal 1. Okay, and that's all they're asking for on this one. Okay, the next one, you got 2x minus 6 over x minus 1, and it's graphed here. The x-intercept is at 3, 0. The vertical asymptote looks like it's at y equals positive 1. I'm sorry, x equals positive 1 right here. So x equals 1. The horizontal asymptote is at y equals 2 right here. There are no holes in this either. We can factor this into 2 times x minus 3 over x minus 1. There's no factors in common. In other words, there's nothing I could cancel out. Anything I could cancel out means there's a hole there. But there are no holes on this one. Domain x such that x does not equal 1. And then range y such that y does not equal 2. All right. Let's look at number 3. Okay, number 3 is interesting. X-intercept, oh, excuse me, -1, 0. Vertical asymptote, no, none. Horizontal asymptote, there isn't one. Now, hole. Let's factor this. This is going to be x plus 1, x minus 1 over x minus 1. So that means there is a hole. We'll go ahead and tell you what it is. It's at 1, 2. Here's how you find that. You take the factor that it has in common, set it up equal to 0. That's your x value. Okay, so the next thing we do is we go ahead and cancel out these and simplify it into x plus 1. And then we take this x value and plug it in for x. So 1 plus 1 is 2. That's where the 2 came from. The domain, since there is a hole at 1, 2, here's how we write domain. We write x such that x does not equal this x value, 1, because there's nothing on that graph at 1, 2. And then we write y such that y does not equal 2. All right. Okay, so this one, I'm going to go ahead and simplify this. X plus 5 over x plus 4, x plus 5. Okay. Well, there we go. Okay, this graph, this number 4 graph, does not have an x-intercept. Vertical asymptote at x equals -4. Horizontal asymptote at y equals 0. It does have a hole, and the way we know, again, is because x plus 5, it has the same factor in the numerator and denominator. So that means it does have a hole. Here's how we find it. We set this up equal to 0. So we set up the x plus 5 equal to 0. So that means x equals -5. So the x value is -5. And then we simplify the whole thing, 1 over x plus 4. And we plug in a -5 right here. So 1 over -5 plus 4 is 1 over -1. And that equals -1. So my y value is -1. This is the last one we're going to do. Notre Dame just took the lead, so I got to go. But anyway, we're almost at 20 minutes too. Domain. All right, so the domain is all real numbers x such that x cannot equal -4. It can also, and we'll just put a comma, it can also not equal -5. So you got to put the vertical asymptote in and the x value for this hole. Okay, and then the range would be y such that y does not equal -1 or 0, because I got my -1 here and my 0 here. So my horizontal asymptote and also the -1 where the hole is. All right, we're done.